Trigonometric functions, unit circle approach. You may have seen the definitions of trig functions using a right triangle, sometimes soka toa, like this. Let me show you. If you have not seen this before, you will see at some point when we have a right triangle with some angle t, let's say, and this is opposite of t, adjacent to t, and hypotenuse. Then so ka toa, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, you will see this later. But here I am defining those trig functions using unit circle approach. So this, let's say this is a unit circle, means the center is at origin and the radius is just 1. So this is 1 0, this is negative 1 0, and this length is 1, so this is 0 1. Now we can find the length of the circumference. The length of the circumference is given by 2 pi radius, which is 1 in this case. Okay, 2 pi. So the length of the circumference is just 2 pi units. Now we are given any real number t. Okay, t, any number, any real number, could be positive or negative. Then we can represent that t. If this is positive, then we can go from here. Let's start from here and go up in this direction. Let's say t, any number, okay, any length, and up to this. If t is negative, then we have to take, if t is less than 0, then we'll take the length of absolute t and we go downward. Okay, this is the length t, and now we want to represent this t on the circumference of this unit circle. Okay, if this t is bigger, the length, if the length of this t is bigger than 2 pi, then we have to go more than once, because the whole length is 2 pi. So if this is bigger than 2 pi, then we have to wrap twice or 3 times or 1.5, anything. Let's say this is t, then we just wrap here up to this, move this, and let's say we are here. Okay, this is just here, and denote this point by xy, p xy. Okay, then let's go back up here. Let t be a real number and p be the point on the unit circle that corresponds to the t. Then the sine function, we just write sin, but it still says sine of t is given by y coordinate. Okay, sin, sine alone does not make sense. These 6 trig functions always take some number, and which is angle later, but don't write just sin. Sine of t is y. Similarly, the cosine function is defined by the x coordinate. Cosine of t is x, and if x is not equal to 0, then tangent of t is defined by the ratio y over x, and cosecant is defined by 1 over y if y is not equal to 0, because we cannot divide by 0, and secant function is defined by 1 over x if x is not equal to 0, and cotangent is defined by x over y when y is not equal to 0. And from these definitions you can see cosecant is reciprocal of sine, and vice versa. Sine will be reciprocal of cosecant. Same thing here. Secant is reciprocal of cosine, and cosine is reciprocal of secant. Same thing here. Cotangent is reciprocal of tangent, and tangent is reciprocal of cotangent. Okay, final.